Okay, hello Wahyu and good morning. How are you today? I hope you are doing well. So before we start, let me introduce myself. My name is Ayudya AStiti, and today we're going to learn about limits and limit function. So before we begin, let me ask you a simple question. Have you ever tried to reach a destination but never actually arrived there because you keep moving closer and closer?
Hmm, like when we walk toward a wall and stop just before touching it?
Exactly. So that idea is very similar to the concept of a limit in mathematics. And today we will learn about what is a limit and how to calculate limits, why limits are important and how limits are used in real life. And let's get started. So, okay, first imagine when you walking towards a closed door, you take a step that cover half the distance, then half of remaining distance, then and again, half again. So each step gets you closer and closer to the door, but you stop right before touching it. So many students think that a limit is simply the value we get after substituting a number into a function. However, a limit is actually about what happens when a value gets closer and closer to a certain point. And think about, like I said before, this situation, imagine that you are walking toward a door, you move halfway to the door, then half of the remaining distance, and then half again. So each steps bring you closer to the door, and even before you touch the door, we can clearly see that you are approaching it. And this idea of getting closer and closer is the foundation of limits. So, and in mathematics, instead of observing a person approaching a door, we observe the value of a function as the input approach a specific number.
So, a limit is about getting close to a value, not necessarily reaching it.
Exactly, Wahyu. So a limit focuses on the behavior of a function near a certain point. Sometimes the function reaches that point and sometimes it does. But what matters is the value the function approach. And let's look at a simple example. Okay, so consider the function f times x equals 2 times x plus 1. Suppose x approaches 2 and you can see at the screen this table. Notice that as x gets closer to 2, the function value gets closer to 5. Therefore, we say that the limit is 5.
Even before x becomes exactly 2, the value is already very close to 5.
That's correct, Wahyu. So this is why limits are often described as the value that a function approach. Next we have direct substitution method. So how it works? So for most continuous function, finding a limit is simple. We can directly substitute the target x value into our formula. And always try direct substitution first. So let's solve an example together. Let's find the limit of x squared plus 2x as x approaches 4. Since the function is continuous, we can directly substitute the value of x equal 5 and equal 4. And we get 4 squared plus 2 times 4 equals 16 plus x is equal to 24. So therefore, the limit is 24.
That seems easy.
Yes, for many functions, we simply substitute the value of x. However, some limits require an algebraic manipulation before substitution. Okay, next we got why are limits are important. So, many students ask me, why do we need to learn limits? why its limits is important. So the answer is simple. Limits are the foundation of calculus. Without limits, many important concepts in mathematics will not exist. For example, limits help us define derivative, and a derivative tells us how fast something changes. For instance, the speed of moving car, the growth of population, or the rate at which water fills a tank. And limits also help us define integrals. As you know, integrals are used to calculate areas, volume, and accumulate quantities.
So limits are connected to many topics in mathematics.
Absolutely correct, Rahul. So when you continue studying calculus at the college, maybe you will see limits almost everywhere, and that is why limits are often called one of the most fundamental ideas in mathematics. Okay, next we get limits in real life and how we application of we application the limit. And the first application is in physics. So suppose a car is moving along a road. We may know the average speed of the car over 1 minute. However, what if we want to know the exact speed at one specific moment? So to answer that question, mathematicians use limits. Limits help calculate instantaneous velocity, which means the speed at an exact instant. And the second application is in engineering. So engineers use limits when designing bridges, roads, buildings, and machines. So they need accurate calculation to ensure safety and efficiency. And the third application is economics. So economists use limits to study how cost, profit, and revenues change. For example, they can predict how a small change in production affects total profit. And the fourth application is computer science. So limits help us analyze algorithms and estimate how quickly a program runs when the amount of data becomes very large.
Wow, I thought limits were only used in mathematics class.
Okay, so as you know, many people think that it's first, but in reality, limits are used in science, engineering, technology, economics, and many other fields. So that's all for me, and we have to review the material first. What have we learned today? So we learned that a limit describes the value a function approached as the input approach a specific number. And we also learned how to read limits notation correctly in English. Then we solved several examples of limits and discussed situations where direct substitution works and situations where algebraic simplification is needed. And after that, we explored the importance of limits and their application in physics, engineering, economics, and computer science. And finally, we learned that limits are the foundation of calculus and help us understand change and motivation and motion in the real world.
Today I learned that limits are not just about finding answer. They help us understand how functions behave and how mathematics can describe real life situations.
Okay, exactly. Excellent summary, Wahyu. And remember, a limit is not always about reaching a value, it is about approaching a value. And once you understand this idea, many topics in calculus become much easier to learn. And thank you for you, Wahyu, for your attention, and you always answer my question. And see you in the next lesson. Bye bye.